Now let us talk about Layer 2 scaling solutions. As we mentioned before, Layer 2 scaling solutions depend on the main network for security. So they do not have any consensus processes and are not independent blockchains. These solutions involve processing transactions off-chain. Let us start with rollups. As the name suggests, these scaling solutions bundle many transactions together in a batch, and then only the aggregates of the batches are submitted to the main chain. The data is rolled up and submitted to the main chain by an actor called the sequencer or serializer, who can be centralized or decentralized. So, how does it exactly work? I am borrowing the explanation from Vitalik Buterin's article on this subject. Rollups are implemented as smart contracts on the main chain, say on Ethereum. The smart contract maintains a state root, which is the Merkle root of the state of the rollup. The state root contains account balances, contract codes, etc. that are inside the rollup. The batch is a collection of transactions in a highly compressed form together with the previous state root and the new state root. The contract checks whether the state root in the batch matches its current state root. If the state root of the batch is different from the current root, it switches the state root to the new state root. Now the question arises, how do you know that the transactions in the batch are valid? This is the basis of the classification of rollups. Two families of rollups, optimistic and zero knowledge, use two different kinds of proofs, fraud proofs and validity proofs, respectively. Now, let us talk about these two types of rollups, optimistic and zero knowledge or ZK. On a high level, the basic difference between these two types is that in the case of optimistic rollups, it is assumed that all the transactions in a batch are valid unless this assumption is proven wrong. But zero-knowledge rollups do not make such assumptions. Okay, let us dig deeper into these two types.